In this lesson, we're going to be putting together a lot of things we've learned over a lot of different units. We have to be able to balance formulas. We have to be able to write those formulas from the names. We have to be able to predict the products of equations, and to do that we have to be able to classify those equations, those types of reactions. And then we get to the stuff we're doing in this unit, where we're learning to do stoichiometry. We have to be able to calculate our way from one reactant to the other and determine which is the limiting reactant. Once we find the limiting reactant, we use that limiting reactant to find a theoretical yield, and with a theoretical yield, we use the actual yield to find a percentage yield. A lot of stuff to put together, but this is kind of a culmination building up to this point where we can do some real stoichiometry problems. So here's the homework problem you were assigned. If 30.0 grams of ammonium sulfate is reacted with 50 grams of calcium phosphate in an aqueous environment, and 15 grams of solid product is collected, what is the percent yield? So this is going to be a rather long problem, okay? And it's going to take up probably all of a page, if not more than one page, depending on how big you write. But it's all pretty much mass-to-mass calculations. The rest of the stuff is pretty simple, straightforward, easy stuff to do if you've been paying attention and doing the work. So we can choose either ammonium sulfate or calcium phosphate to be the starting amount for determining the limiting reactant. It doesn't matter which one. Since most students usually start with the first one listed, that's what I'm going to start with, okay? So we're going to put down, well, let's see. Do you want to balance the equation first, or do you want to balance the equation first? Okay, so ammonium is NH4. Sulfate is SO4. Since ammonium has a 1 plus charge and sulfate has a 2 negative charge, I need 2 ammoniums to balance the sulfate's charge. All ammoniums are always aqueous, so you get that from the solubility rules. It's in an aqueous environment, so if this is soluble, then it's going to be aqueous. And then we're reacting that with calcium phosphate. Calcium is Ca, phosphate is PO4. Calcium has a 2 plus charge, phosphate has a 3 negative charge, so to balance this out I need 3 of these and 2 of these. And while, let's look it up here on the solubility rules. It says here that phosphates are mostly insoluble. There's an exception for group 1 in ammonium. Well, this is not in group 1, this is in group 2, so this must be solid. Alright, so if a reaction is going to occur, it's going to be double replacement. Okay? I've got a 2-part chemical here, and I know that it's a 2-part chemical because it's ionic. Ionic compounds can be identified in one of 2 ways. If there's a polyatomic ion present, it's an ionic compound. I got 2 polyatomic ions, so I know it's ionic. This one's also ionic because there's a polyatomic ion there, that PO4, that phosphate is a polyatomic ion. It's got 2 ionic compounds, so this must be double replacement. This front part of this chemical is going to have to join up with the back part of this one. I'm going to balance it later after I have a chance to find out whether I have a driving force. Calcium is going to join up with sulfate. We go back to the solubility rules and we see that sulfates are mostly soluble unless they're bonded with calcium. So since this sulfate is bonded with calcium, this is a solid. And that's the driving force we need for this reaction to move forward. So calcium has a 2 plus charge, sulfate's 2 negative. That's balanced as it's written. Phosphate, we said, has a 3 negative charge. Ammonium has a 1 plus charge, so we're going to need 3 of those. And we're ready to balance the equation with an atom inventory. You always have to have an atom inventory. So we have nitrogen and hydrogen, sulfur, oxygen, calcium, and phosphorus. We want to have a sort of grid or sort of mini spreadsheet kind of thing so that we can balance each of these elements here, the atoms of each of these elements, so that we don't violate the law of conservation of mass. So at the moment I have 2 outside the parentheses here. That means I've got 2 nitrogens, and since I have 4 hydrogens in the ammonium formula, the 2 makes that 8. I've got 1 sulfur. I've got 4 oxygens here, but I've got 8 over here. So don't save the pencil graphite. Always write it out so you can kind of keep up with it. 4 times 2 is 8. So we've got 12 oxygens at the moment. 3 calciums and 2 phosphoruses. On the right-hand side, I've got 3 times 1, or 3 nitrogens. 4 times 3 are 12 hydrogens. I've got 1 sulfur, and I've got 4 oxygens here, plus 4. So I currently have 8 oxygens. I've got 1 calcium and 1 phosphorus. So you always balance the hydrogens last and oxygens next to last. So we could start with the nitrogen. I've got 2 on the left, 3 on the right. If I put a coefficient 3 here and a coefficient 2 here, that should make the nitrogens even out. So let's see, that's going to change the nitrogens and hydrogens and sulfurs and oxygens on this side. Over here it's going to change nitrogens and hydrogens and phosphoruses and oxygens. So let's recount everything then. I've got 2 nitrogens because of this 2 here, then times 3, that's 6 nitrogens. I've got 4 hydrogens, times 2 is 8, times 3 is 24. Now y'all see where I got 24 from? Okay. I've got 3 sulfurs, and I've got, and that one you want to write out too. It's up to you. 3 times 4 is 12 oxygens here, plus the 4 times 2 are 8 here. So currently I've got 20 oxygens on the left. All right, go to the right over here. I've got 1 nitrogen in the formula, times 3 is 3, times 2 is 6. 4 hydrogens, times 3 is 12, times 2 is 24. And let's see, oxygens. I've got 4 here, times that 2 is 8, plus the 4, that's 12. Okay, and got to balance the, or can't recount the phosphoruses. I've got 2 of those. All right. So nitrogen's balanced, hydrogen's balanced, sulfur's not balanced now. Let's go over here to the right-hand side and put a coefficient 3 in front of the species that contains the sulfur. And that's going to change the number of calciums and sulfurs and oxygens. All right, so I now have 3 calciums, 3 times 1 for 3 sulfurs, and let's balance I'll recount the oxygens. 2 times the 4 is 8. 3 times the 4 is 12. That's 20 oxygens, and that's what we need to balance out the oxygens. So if you save oxygen for last, it almost always works out for you. Okay, that's the one you save for last, and hydrogen next to last. That mostly applies to combustion reactions, but if you always do it that way, it's going to work out for you most of the time. All right, so let's start with a 30 grams of ammonium sulfate to start our first stoichiometry problem. So I'll put 30 grams, 30.0 grams of ammonium sulfate. That's this compound here. And we're going to put it over 1. Notice I turn my paper sideways, okay? I don't have it like this, all right? I turn it this way because these problems take up a good bit of space. And that's just a good little tip you can use to help you do these kind of problems in the space. But if you write small, it's okay. You can put it any way you want to, but just to me it's easier if I write it sideways. All right, so I need a molar mass ratio here in order to convert from grams to moles. So I'm going to calculate the molar mass of ammonium sulfate. I've got nitrogen and hydrogen and sulfur and oxygen. Nitrogen is 14.0067. That's its atomic mass. The molar mass is the sum of all the atomic masses of all the atoms in a formula unit in units of grams. So I've got that. I've got 1.00794 for the mass, the atomic mass of hydrogen. Sulfur's is 32.065. and oxygen is 15.9994. I've got 2 nitrogens in the formula. I've got 8 hydrogens, 1 sulfur, and 4 oxygens. You ignore coefficients when you're calculating the molar mass. Okay, I have students who will, instead of doing 2 nitrogens here, they'll say that must be 6. That's not the way you do it. You only multiply by the number of atoms in the formula unit.
I can't see that anymore, but
okay. All right, so we're ready to do the math now. It's important to keep your numbers lined up vertically, like you did in when you start learning decimals? Was it 3rd grade? Nobody remembers, do they? Okay, too long ago. I know when you're in 1st grade you kept everything lined up neat, but you didn't have any digits missing out of the ones place. Is that right? Oh, I left out a 3. I knew there was something wrong there. It should be 352. Okay, we got a bunch of empty slots in this thing. I've got an empty slot right here. I've got an empty slot here, and here, and here. Okay, I want to add all these numbers together. We don't put zeros there to line everything up because that would be lying about the precision. Those last 2 digits are going to be rounded off. And we get 132.140 grams of ammonium sulfate. And that's equal to 1 mole of ammonium sulfate. Now, it's important that you write this equality statement, because without that equality statement, you don't have a justifiable reason for writing this conversion unit. We want to match the units and species we have here with whatever we put on the bottom. So it's the left side of this equality statement down here we want to put on the bottom, because it has the same units and species. Grams are units, species is ammonium sulfate. So we're going to put 132.140 grams NH4SO4. Why did I do it that way? I don't know. Parentheses don't go around the sulfate, it goes around the ammonium. Alright, and then we want the other side of the equality statement to go on the top. And we're ready for the molar ratio step. But before we do that, let's cancel out the units and species we can cancel out. So these grams are going to cancel. the species of ammonium sulfate is going to cancel. And now we have moles of ammonium sulfate, and we want to get to whatever the solid is in this problem. Well, first off, we've got to get to the other reactant. We've got to find the limiting reactant. To do that, we've got to go from ammonium sulfate to calcium phosphate. So I want to go from 3 moles of this to 1 mole of that. I'm going to put the 3 moles, this comes from this coefficient 3 here in front of the equation, 3 moles of ammonium sulfate. And I'm going to put the 1 mole from the coefficient that's implied here on the top, 1 mole of calcium phosphate. And we want to cancel units of moles and ammonium sulfate. All right, then we want to find the molar mass for calcium phosphate to get that into grams. The atomic mass of calcium is 40.078. Phosphorus's atomic mass is 30.973. 762. And oxygen is 15.9994. All right, in this formula then there are 8 oxygens, there are 2 phosphoruses, and there are 3 calciums. So I've got 120.3234, 234.
Where's it at?
All right, adding all these up, I get 310.17444. I've got 2 empty slots in these last 2 columns, so those 2 digits get rounded off, and we're going to round that off then to 310.174 grams calcium phosphate, and that's equal to 1 mole of calcium phosphate. And so I have an equality statement now to justify writing this conversion unit I'm going to put in here. This time I want moles. Since I have moles of calcium phosphate on the top here, I want to put moles on the bottom. The last time we did a molar ratio or molar mass calculation, we put moles on the top. Now it needs to go on the bottom because I have moles on the top here. And we cancel out units and species where we can. And we're left with grams of calcium phosphate, which is what we're looking for. So now we're ready to do the math. We're going to multiply everything across the top, hit enter or equals, then divide by this on the bottom, hit enter or equals, divide by this on the bottom, hit enter or equals. And I get 23.4731345543. and that's grams of calcium phosphate. And we've got to round that off now. When we're doing multiplication division like this, we're going to look and find the numbers that are measured or calculated. And that would be this number, and this number. Everything else is counting numbers, okay? It's only the measured or calculated numbers that are used for figuring out what your significant digits are, and, at least in multiplication division. And this is the one with the least digits. So we want our final answer to have that same number of digits. So we want 3 digits in the end. You underline the insignificant digits, draw an arrow to show that we're rounding off. That's the only acceptable operator to show you're rounding off. 23.7 makes the 4 round up to a 5 grams of calcium phosphate. And that number is what we're going to compare to our starting amount. Okay? All right, now we're going to look in the problem and we see that we have 50 grams of calcium phosphate. So let me tell you what this number right here tells you how much calcium phosphate is needed to completely react with all the ammonium sulfate. This is how much we need. We got way more than we need. That makes sense? Therefore, calcium phosphate is in excess, and that means that ammonium sulfate must be the limiting reactant. Okay? All right.
Can you do that one more time?
Say that last thing again? Okay. Since the amount of calcium phosphate we calculated, that tells us how much we need of that calcium phosphate to completely react with 30 grams of ammonium sulfate. Since we have far more than that in actuality, this is a number we calculated. It's a theoretical number. It's how much we need to completely react with all the ammonium sulfate. We've got way more than we need. Therefore, we're going to have it left over. That's called in excess. All right? If that species, calcium phosphate, is in excess, then ammonium sulfate must be the limiting reactant. So the reaction stops when the ammonium sulfate runs out. Okay? Now, in order to calculate the theoretical yield, we're going to start with ammonium sulfate. And luckily, we happen to start with that up here. So the next problem is going to start exactly the same as this problem. Okay? We're not always that lucky, but this time we are.
So why did you round 9 numbers again?
Huh?
Why did you round 9 numbers again? I thought it was only supposed to be like 6.
We're rounding off this answer to 3 digits because the measured number in the problem had only 3 digits. The 2 calculated numbers had 6 digits. But of the measured and calculated numbers, this is the only one, this is the one with the least digits. That's how we want only 3 digits in our final answer. All right, so we're starting with our limiting reactant. That's ammonium sulfate. It's going to start exactly as this one started. That doesn't always happen. Be careful. Don't just assume you're going to start with the same thing. You can't. You have to start with the limiting reactant, okay? Okay. Now in this next problem, we're not going to the other reactant here. Now we're going to try to find the amount of product. And it says we're looking at the solid product collected. Okay? When we looked at the problem, the balanced equation, and figured out our physical states, we figured out this was our solid product. Okay? And luckily, that's the case. Now, this is kind of an aside here, but if this wasn't, calcium phosphate wasn't in excess, we'd have some solid left over. Okay? Actually, it will be some left over. That's not good, because there'll be some of this mixed in, but that's okay. We'll just assume this is the one we're looking for because that's what I've taught you so far, okay? I meant to do it the other way, so this would be a limiting reactant, and I just completely missed these two numbers. That's okay. All right. So we're going to calculate to the product we're looking for. That means we have 3 moles of calcium sulfate. Let's cancel out what we can cancel out here, as we did before. Okay, and so now we're going to need a molar mass calculation for calcium sulfate. Let's see, I meant to leave enough room up here so I can calculate that. I'll write it a little bit smaller this time so I can calculate it.
How did you get 3? Is that a 3 and a 3?
Yes.
Why did you do that again?
Because there's a coefficient 3 here in the problem. That's where that molar, 3 moles of calcium sulfate comes from. 3 moles here.
What about the other one?
The other 3 came from this 3 moles. All right, we got 1 empty slot on the right. Last digit gets rounded off. 136.141 grams of calcium sulfate equals 1 mole of calcium sulfate. And so, since I've got moles on the top here, I want moles on the bottom here, and the side of the equality statement with moles is right here. And the side of the equality statement with grams, which is what we're going to look for, is there. 136.141 grams of calcium sulfate. Cancel out moles. Cancel out calcium sulfate. And we're ready to do the math. So we want to multiply everything across the top. Hit enter or equals, multiply by one thing on the bottom, hit enter or equals, divide by one thing on the bottom, hit enter or equals, and then divide by the other thing on the bottom, hit enter or equals. And I get 30.916776903. That's grams of calcium sulfate. Again, we want to round off to the least digits. There's 3 here. I want 3 here. And I get 30.9 grams of calcium sulfate. Okay, that's our theoretical yield. Okay? That's the theoretical yield. Almost there. Now it's the percent. So the problem says we have 15 grams of solid. We calculated 30.9 grams. This is the theoretical yield. This, you'll never get this amount. If you get this amount in your problem, you either lied or you made a mistake. Okay? Because you can't have a perfect result like that. It ain't going to happen. All right? There's always some left over, left back, something. something doesn't react. It's never perfect, okay? All right, so we're going to take that 15 grams of solid that was collected, and we're going to put it over the 30 grams that we calculated as our theoretical yield. Percent yield is always actual yield, which is that 15 grams, the amount collected, actual yield over the theoretical yield times 100. So it's 15 grams of calcium sulfate over 30.9 grams of calcium sulfate. Okay? Then times 100. Now, grams are going to cancel. All right, I'm sorry I didn't show it to you on camera. 15 grams of calcium sulfate, that's the actual yield, over 30.9 grams of calcium sulfate, that's the theoretical yield, then times 100. Units are always going to cancel. If percentages are set up properly, you will always cancel units. Okay? The percentage is always a unit less amount. It's not always a species less amount, but it's a unitless amount. Okay? In this case, it happens to be species less, but not always. So we're going to take that 15.0 and divide it by that 30.9, hit enter, and then multiply that times 100. And I get 48.54 and a bunch of other numbers. Percent. We want to round that off to 3 significant digits because we're starting with 3 significant digits here. 1, 2, 3. Round it off. And we get 48.5% yield in calcium sulfate. And that's the percent yield. Okay? Any questions? All right. Long problem. That's the nature of stoichiometry. Yep. Okay, what I meant by 30.9 grams never being, you can never actually get that amount out, okay? This is your actual yield, 15 grams. You're never going to get 30.9 grams, okay? If you were in a lab, to do a lab where you were expecting a theoretical yield of 30.9 and you actually got 30.9 grams of solid, there was some kind of experimental error. You ought to run your experiment again. Close to that's not really a problem, okay? In a manufacturing process that's really efficient, you might get 98% or something. That's possible. But getting actually 100%, you can't do that. It's not possible. Okay? So adding up all the points, 38 for the balanced equation, 39 for the atom inventory, 4 for identifying the limiting reactant. Each of the stoichiometry problems, mass stoichiometry is worth 46. The molar mass calculations, 33, 27, 27. Percent yield calculations, 20. Add it all up, I got 280 points total for this problem.